Okay, so this video is just for a little bit of extra practice that is in line with Honors Math 3, Unit 10, Objective 3A. So it's the first half of Objective 3. So I broke this up into two videos after all. So the first video covered petals, so I won't be going over any petal graphing for this one. And so I will just be doing cardioids and limacones. But I'm really going to be graphing them as if they are the same thing, and I'm not going to use the full table to graph it. I'm going to be going over how do we use the A and the B values to help us graph it in addition with the knowing the orientation. Okay? All right, so our very first one that we're going to take a look at is R is equal to 6 plus 6 and then sine of theta. So I know it is a cardioid or a limacone because it has an addition or a subtraction, right? So if there's an addition or a subtraction, we're working with either a cardioid or a limacone. Keeping in mind that a cardioid and a limacone, they are just hybrids of each other. So we graph them the same, and then just how they roll out from each other tells us what we're working with. Okay, so I'm just going to go ahead and do my kind of my XY axis here. So this is kind of a shortcut way for us to graph without having polar paper or drawing those concentric circles. So for this one right here, so I want to look at the orientation. And so when I look at that orientation, what I'm looking at is I have an addition and I have sine theta. So I have to think about what do I know about adding and sine theta. So I know sine theta is positive when I go up, so that gives me the orientation of the graph. So that means that I'm not going to draw a graph here, but so the graph would be like up here somewhere. So then the first thing I'm going to go ahead and do, so I know that I'm going to be going upwards from this way right here. So I have my shoulders, so I'm going to graph my shoulders. So I look at this value right here. So this is equal to 6. So then I'm going to go out 6 units, but I'm going to scale this by 2. So I'm going to call this 2, 4, 6. So we'll go 2, 4, 6. And then I'm going to go the other way as well. And I'm going to put dots right there. Okay, so those are the shoulders of the graph. And I know I'm going to have a pull point, so I'm going to go ahead and do that. And then to find the diameter of the outer circle, I add my values, or my constant and my coefficient together. So I'm going to take the 6 and the 6 here, and I'm going to add those together, and that gives me the diameter of the outer circle. So again, I'm going to count by 2s. So 2, 4, 6, 8, 10, 12. So 6 plus 6. And then to find the diameter of the inner circle, I subtract those same two values. So I'm going to take that 6 again, and I'm going to subtract it from 6. And so because 6 minus 6 is equal to 0, that means there is no inner loop. And so as soon as we get that no inner loop, then that means we are actually graphing a cardioid. Okay. So then now all I have to do is connect those values and create my cardioid. So there is the graph of a cardioid, okay? So then to find the start and the stop point, what I need to do for that is I need to let theta equal 0. So I'm going to go ahead and do that next. So this would be where kind of that T table comes into play, so theta and R. So I'm going to let theta equal 0, and then I'm going to replace theta with 0. So I have 6 plus 6 sine of 0. And then I know that the sine of 0 is 0. So that would just be 6 plus 0 or 6. So when I look at this, right, so this is where theta is equal to 0, is everywhere along this line. So I have kind of 3 choices when I look at just the graph of where my start point could be. So that's why I always need to check at that theta equals 0. So then my start point is here, and then we're always going to go in a counterclockwise direction towards my next plotted point, which in this case is pi over 2. Okay? All right, so let's go ahead and do another one. So let's take a look at number 2. So for this one here, I'm going to do R is equal to 4 minus 6, and then cosine of theta. Okay, So let's go ahead and take a look at just kind of a little sketch here. All right, so for this one right here, so the first thing I'm going to do is figure out my direction and my orientation. So I'm going to take a look at the fact that I am subtracting here, and I also have a cosine, so a negative cosine. So because I have a subtraction, that means I'm either working with a cardioid or a limacon. And so when I look at this one, I want to say, all right, so I have a negative subtraction problem with a cosine. So where is cosine negative? Oops, that's where it's positive. Let's try that again. So cosine is negative when I head towards the left. So in general, the graph is going to be over here somewhere. Okay. All right, so that means my shoulders are going to be up and down. So I take a look at that kind of first value right here, 4, and that tells me how far up and down to go. And so I'll have a value here and here. So again, I know my shoulders are here and here because I knew the direction of my graph. And then from there, I want to add together my constant and my coefficient, right? So I want to take that constant value of 4 and that constant or coefficient of 6, and I add those two together, and that gives me the outer diameter. So 4 plus 6 is 10. So I'm going to count out 10 towards the left. And there is my outer diameter. And of course, I'll always go through the pole as well. Or not always, but for my cardioid and limacon and pedals that I'm working on. Okay, so then from here, then I want to subtract those same two values. So I'm going to go back to that 4 and the 6, and so I'm going to subtract them, but I'm looking to get a positive number, right? So I'm going to do b minus a. So 6 minus 4, so that gives me a value of 2. And so because it's not 0, that means I do have an inner loop, right? So there will be an inner loop with a diameter of 10. So then therefore my graph will be a limacon because it has that inner loop. So then I'm going to go 2 units, 1, 2, towards the left. And then I'm going to graph my cardioid piece first, which is kind of my outer loop. And then I'm going to graph my inner loop to give me my limacon. Okay, all right, let's do another one. So we're going to do r is equal to 1 plus, oops, I meant to do minus. Let's try that again. 1 minus, and then 4 sine theta. Okay, so again, I know I have a cardioid or a limacon because I have a subtraction in the problem. And so I'm going to take a look at the fact that I have a subtraction of a sine. So where is sine negative? Sine is negative down below because it is a y value, right? And so that means my graph is going to be something here. Maybe there's an inner loop, maybe not. And then I forgot to say this, so I'm going to say it now. Like, you should be pressing pause and trying these problems before I actually do them for you. Okay. So I know my graph is there, so I know my shoulders are going to be along that horizontal line, radial line. So I have that. And so to find my shoulders, I always look at the constant, so that would be 1. So then I'm only going to go out 1 unit to get those shoulders. And then I'm going to take the value for A and B. So my A was 1 and my B is 4. And I'm going to add those together, and that gives me the diameter of the outer loop. So then that means I need to go 5 units down for my outer loop. And then I take those same two numbers and I'm going to subtract them to see if I have an inner loop. So when I do subtract them, 4 minus 1, I get a value of 3, so then I will have an inner loop, and that will be right there. And then, of course, it's going to go through the pole. Okay? All right, so then I'm going to go ahead and draw that cardioid component first, which is that outer loop, and then my inner loop so that I have a limacon. Okay, so I realized I forgot to do the start and stop on the previous problem, but let's go ahead and do it for this one here. So to find my start and my stop, I'm going to always let theta equal 0. So I'm going to take my original equation and then replace theta with 0. So sine of 0 is 0, so I'll have 1 minus, sine of 0 is 0, so I'll have 1 minus 0, which is just 1. So I had 3 points on that radial line of theta equals 0, so the one that is actually my start point is right here at the radius of 1, and then we head in a counterclockwise direction, so then there would be my indicated direction. Okay, all right, so let's do another one. So let's take a look at number 4. Okay, so I know I have a cardioid or a limacon because I have that adding and subtracting. And so let's go ahead and figure out my orientation. So I have a positive cosine graph, right? I'm adding cosine, so adding cosine. So I know cosine is my x value, so positive when I head to the right. So then I know my basic direction is going to be pointed to the right. And so I'm going to mark my shoulders first. So my shoulders are always a constant, and I know they're on the vertical line, right, the vertical radial line. So then I'm going to go 5 units up and down. And I'll pass through the poles, so let me put that dot there. And then I know that I add my constant value with my coefficient. So I'm going to add 5 plus 5 for a value of 10. And that gives me the diameter of the outer, right? Diameter of the outer. So I'm going to head to the right, 10 units. And then I take those same two numbers that I had, 5 and 5, and I want to subtract them. And that gives me a value of 0. So that means there is no inner loop. So if there's no inner loop, then I have a cardioid. And so I'm going to go ahead and graph just that piece of it then. So I'll get my cardioid. Okay? And let's do the start and stop here. So in order to do that, I'm going to let theta equal 0 always, right? Theta is equal to 0. And so I'm going to take my original equation and replace theta with 0. And then I know the cosine of 0 is 1. So I will have 5 plus 5 times 1, which is 10. So when I'm looking at my graph, right, because if I look at where theta is 0, that could be here or here. But now I know that it is at this dot, and then always in a counterclockwise direction towards that pi over 2. And then there is that graph. Okay? All right, and that is it for some extra practice. And if you need anything more, be sure to always reach out to either your teacher, which is either Mrs. Pape, or which is me, or Mrs. Certain.